Properties of exponents, part 1. So number 1 says, fill out the table to derive different properties of exponential expressions. So here we have x to the third times x to the fifth. So remember what x to the third means. X to the third just means an x times an x times an x, 3 of them. X to the fifth means x times x times x times x times x. So that's how it would look expanded out. So if we were to simplify this, we have 3 x's from the x to the third and 5 x's from x to the fifth. So in total, we would have 8 x's. The simplified form would be x to the eighth. So the exponent rule for something like this, when you have 2 exponential terms with the same base, would be to add the exponents. So the rule here is we do the 3 plus the 5 and get x to the 8. So the rule, I'm going to put a little rule here down here. It says the product property. If I have x to the a times x to the b, it's just x to the a plus b. That would be the exponent rule. So let's look at the second rule. So I have x to the third to the second. Well, x to the third to the second means an x to the third times another x to the third, because it's to the second power. So an x to the third times another x to the third. I mean, we could expand this out even farther and say, okay, this is x times x times x, and then times another x times x times x, 3 of them, which would give us 6. So the simplified form is x to the 6. So if you want to create a rule, what we would see is the x to the third to the second would give us, if we multiply those exponents, 3 times 2 gives it 6. So the power of a power property would be x to the a times b. So when it's written like that, we're going to multiply the exponents. Okay, one more rule here. The quotient property. So if we have x to the 7th divided by x to the 4th, if I expand that out, I have x times x times x times x times x. I'll write 7 of them. And then on the denominator, I'll have 4. Now what happens is that these reduce, right? Because x divided by x, or anything divided by itself, reduces to 1. So these will reduce, these will reduce, these will reduce, these will reduce. And all I'm left with is 3. There's just 3 left. So the simplified form is x to the third. So when you have x to the 7th divided by x to the 4th, you get x to the third. So the rule, the shortcut, would be to subtract. So those are the 3 exponent rules we've been working with on this page. So number 2 says, use the properties of exponents to write the simplified form of each exponential expression. So on A, we have x to the second times x to the 9. So from our exponent rule, we have 2 x's, and then we have another 9. From our exponent rule, we're going to add these exponents. So this is going to be x to the 11th. On B, we have x to the 10th divided by x to the 3rd. So the rule we just learned is that when we have division with these exponents, we subtract them. So 10 minus 3 is 7. And then on C, if we have x to the 4th to the 2nd, the rule here is to multiply the exponents. So this would be x to the 8th. So those are our exponent rules. Now D, E, and F, it's the same thing. We just have fractions. So if x to the 7/3 divided by x to the 1/6, remember we subtract the exponents in this situation. So you're going to do 7/3 minus 1/6. And sure, we can get common denominators and subtract the fractions that way, but I'm going to do it a little bit quicker. I'm just going to use the calculator. So let me make sure you know how to use the calculator to subtract fractions. So 7/3 minus 1/6. So I'm going to do 7. There's an ABC button down here. So I'm going to go 7, and then I'm going to hit the ABC 3. So 7/3, and then I'm going to do minus 1 ABC 6, and hit equals, and it tells me 2 and 1/6. But generally, we write these as improper fractions. So to convert this to an improper fraction, if you can see above the ABC in the kind of greenish color, there's a DC. So if I hit second ABC, it converts it 13/6. So this is going to be x to the 13/6. So I just subtracted. I'm going to use the calculator. Again, the fraction button on the calculator would be the ABC button. Okay. So I'm going to let you do E and F. So practice with that fraction button, or you can do it by hand. So G, E, H, and I are a little bit different because they have a little bit of coefficients. So in G, it's the same thing as the first rule. So I'm going to do the x to the 8th and the x to the 3rd are going to go together, and so are the coefficients. So the 2 times 5 is 10. And the 8 plus the 3, the x to the 8th times the x to the 3rd would be x to the 11th. So you don't add the coefficients. It's still a multiplication problem. You multiply those coefficients, the 2 and the 5. It's the exponents in what you add. Similar to H, it's a division problem. So the 6 divided by 2 is 3, but it's the exponents that we subtract when we're using this problem. 8 minus 6 is 2. Now I, we have 2x to the 3rd to the 5th. Remember that 5 multiplies. It multiplies to the exponent. So when I have 2x 3rd to the 5th, sure, I'm going to get my x to the 15. But I'm not going to do the 5 times the 2 to get 10. It's going to the exponent. This is like 2 to the 1st. So 2 to the 5th, because the 5 times the 1 is 5th, I'm going to do 2 to the 5th power. And 2 to the 5th means 2 times 2 times 2 times 2 times 2, which is 32. So this is going to be 32x to the 5th. And if you didn't know 2 to the 5th was 32 and you want a little shortcut with the calculator, if you go 2 yx up here, 5, that would give you 2 to the 5th, it equals, and you get 32. I'm going to let you do the rest on that page. So a little bit more deriving. So if I have 2 to the x to the 2nd, y to the 3rd, this would be like 2x to the 2nd, y, times another 2x to the 2nd, y, and times another 2x to the 2nd, y. And therefore, I have a 2 times 2 times 2, which would be 8. I have an x to the 2nd times another x to the 2nd times another x to the 2nd. That would be 6 x's. And then a y times y times y would be y to the 3rd. That would be the simplified form. So basically, when you have an expression written like that, this 3 goes to the exponent of everything inside. So that's the property. So if I have x times y to the power of a, this is just x a, y a. That would be the rule. And it's very similar in the second rule. So if x to the 4th over y to the 3rd, that would just be an x to the 4th y to the 3rd times another x to the 4th y to the 3rd. Which would give us, x to the 4th times an x to the 4th would be x to the 8th. And then y to the 3rd times y to the 3rd would be y to the 6th. So again, the 2 would just multiply to the numerator and the denominator exponent. So the rule would be x to the a over y to the a. So let's put these in action a little bit. Number 4, use the properties of exponents to write the simplified form of each exponential expression. So this is going to turn into x to the 12th, and this would be y to the 30th. That 6 would multiply to the exponents. Same on b. That 4 is going to multiply to the exponent. So I'm going to have x to the 12th and y to the 8th. C and D are a little bit different just because they have some numbers. So remember that 2 is going to multiply to the exponents in what's inside the parentheses. So that 5 to the 1 is going to become 5 to the 2nd. I'm going to be doing 5 to the 2nd power. And 5 to the 2nd power is 25. 5 times 5 is 25. And then this will be x to the 12th. On D, same thing. I'm going to be doing 3 to the 3rd power. So 3 times 3 times 3 is 27. But it's the exponents in what I'm going to multiply. So x to the 5th times 3 would be x to the 15th. And remember, this is just like a y to the 1, so that's going to become a y to the 3rd. I'll let you do E and F. got a little bit of fractions in it, but that should be okay. Just use the calculator, or you can do the fractions by hand. It's up to you. So now let's put this all together. So there's actually going to be a couple steps with some of these. It says use the property of exponents to fully simplify the following exponential expressions. So on letter A, I have x to the second to the fifth. So I'm going to handle that first. And in that situation, we multiply the exponent. So that's going to be x to the 10th. Now we still have this x to the third. So I'm going to bring that down. And remember, in this situation, now we add the exponents. So it would be x to the 13. B, there's a couple approaches, but I'm first going to bring that 4 in. So if I multiply that 4 in, this is going to be x to the 32. 8 times 4 is 32. And 4 times 3 is 12. And then I can simplify this further because I have the same base. It's both x. 32 minus 12 is 20. Let me do some more. So C, I have 4x to the 2/3 times 3. So remember, I'm going to do 4 to the third. I'm going to handle this first. Whoops. 4 to the third means 4 times 4 times 4. Well, 4 times 4 is 16 times another 4 is 64. Of course, you can use the calculator if you need to. 2/3 times 3 is going to be 2. But if you don't know that, we can go 2 ABC 3 times 3. It's going to be 2. So it's going to be x to the second. Still have our x to the 10. So the x to the second and the x to the 10 combine to make x to the 12th. So it's going to be 64 x to the 12th. D should be fairly straightforward. We have 2x to the third y times a 5x to the y to the 7th. So the 2 times the 5 is 10. Now it's the exponents we add. Now remember, this is like an x to the 1. So x to the third times x to the 1 would be x to the 4th. This is like a y to the 1. Y to the first times y to the 7th would be y to the 8th. Let me do a couple more difficult ones. Let me do F. So the first thing I'm going to handle is here, because this is raised to the third power. This is raised to the third power. So the 2 to the third would be 8. 2 times 2 times 2 is 8. This would turn into x to the 9 because 3 times 3 is 9. And this would be y to the 3. And now I'm going to multiply that to this. So 3 times 8 is 24. X to the 5th times x to the 9th, that would be x to the 14th. We add the exponents. This is a y to the 1st times y to the 3rd would be y to the 4th. Let me do h. So I'm going to bring that 3 in. So I'm going to do 9 to the 3rd. Well, 9 to the 3rd is 9 times 9 times 9. If you don't know that, just use the calculator. That's going to be 729. X to the 5th to the 3rd would be x to the 15th. 4 times 3 is 12. And again, 5 times 3 is 15. So it's going to be z to the 15th. Now remember that 3 goes to the denominator as well. That's going to be x to the 9th down here. And then 1/3 times 3 is just 1. So now we can simplify this a little further. The 729 is just going to stay 729. But to the x to the 15th and the x to the 9th, we do 15 minus 9. It's going to be x to the 6th. The 12 minus 1 would be 11. The z has nothing to subtract with, so just z to the 15th. Maybe I'll do one more. Why don't I do I? So I, we have this to deal with it because raised to the second. So 3 to the second is 9. 1/4 times 2 is 1/2. And then 5 times 2 is 10. Now I'm going to rewrite everything else. These weren't raised to anything. So now let me deal with the coefficients. 2 times 4 times 9. Well, 2 times 4 is 8. 8 times 9 is 72. X to the 4th times x to the 3 is x to the 7th plus a 1/2. So 7 1/2. So if I do, just write that all out. 4 plus 3 plus 1 ABC2, 7.5. Convert it to an improper. That's going to be 15 over 2. So I'm going to write x to the 15 over 2. And then y, if I got y to the 5th, and then y to the 1st, and then y to the 10th. So 5 plus 1 is 6, plus 10 is 16. So this is its fully simplified. Okay, so I'll let you kind of complete the rest on this.